So looking at the performance of our breadth first search and depth first search, there's a lot of things that are very, very easy to do, and then there's some that are going to require more thought. First of all, is that remember the ADT that we had a long, long time ago about adding a node and is adjacent to? Those are all going to run at O of 1. And that's again just to check if their edges are close to one another, whatever we have. And you've seen that done in a lot of the BFS, DFS algorithms that we just went through. That's really very simple to determine. Let's put it that way. But when we're looking at get degree and get adjacent, that's a tricky one because there's two approaches. One approach is to look at every vertex, and that's, if you're doing that, you're basically doubling the number of vertices because you're looking through a map and see if they connect, and think of it almost like the 2D matrix to see what's up and up with all of the different connections. So that could be pretty close to basically V squared. But if you're going to look at a single vertice and looking around it, that's not too bad. It's really the number of edges, but you're going to do it for every vertice. So it's going to be the vertice plus all of its edges, which still isn't all that bad. Now remember, it's not all that bad if it's a loosely connected graph comparatively strongly, where there's a lot more links. This can vary quite a bit as well. It may get up to the V squared, but it could even be larger. Just think of all the, oh, it could be ugly. So that's where things get a little bit more interesting with that. Now, in the overall algorithm that we have here, it's close to code, but by the way, that's just a symbol for infinity. So it could be max or whatever we have in C++ here to get that value. Could be really anything that you want here. But the overall setup when it comes to this type of breadth first search algorithm is, as you can see, it's using a queue. It's going to find everything that we just did, starting with a starting point and then going from there in our scan, update, and, well, drop type of item for them. There's, matter of fact, there's the in queue, and then there's the DQ that we have right there, and checking to see what we've got. There's our while loop to keep going until our queue is empty. So the code for this isn't all that bad, but man, all of the data structures behind it, of the vectors, the queue representing the graph, that's a lot of work behind the scenes and just getting this all set up.